Welcome back to the Arms Race, a show I randomly made up in my head where I look at random ARM devices. And before you ask, yes, I will eventually try out RISC-V. First on the Arms Race we had the Pinebook Pro, then the Box86 Model A, and now we have the Raspberry Pi 5. If you've watched any of those videos, or really just any video where I test niche hardware, you'll notice that I tend to include video games as part of the testing. There are a few reasons for this, but the main reason is because it provides a challenge. These devices are not designed for gaming, but if you wanted to game, how far could you go? I have a more in-depth video coming up where I talk about general usage of the Pi, and other kinds of benchmarks and stress tests. But since I ended up testing quite a lot of games, mostly just out of curiosity and the fact that I got carried away a bit, I figured I'd make a dedicated video about it. But before we get into that, let's have a quick overview of the Pi's hardware, just so we know what we're working with. We have a Broadcom BCM2712 system on a chip, which features a quad-core ARM Cortex-A76 CPU and a Video Core 7 GPU, with support for Vulkan 1.2 and OpenGL ES 3.1. The Pi is available with either 4GB of RAM, which retails for £55, or 8GB of RAM, which retails for £79. Both prices on amazon.co.uk. I have the 8GB model, but depending on the project, the 4GB model, or even a previous gen Raspberry Pi may be perfectly adequate. I actually wanted to buy an SBC that had an RK3588, like the Orange Pi 5, but they're kinda pricey and I'd also have to wait a long time for shipping, which I just can't be asked for at the moment. In typical Raspberry Pi fashion, the Pi 5 uses a microSD card as the default boot device. I'm using a 128GB SanDisk Extreme Pro. It's also possible to install an NVMe SSD with an extension, which I might buy in the future, but for now I'm just using the microSD card to keep costs down. I'm also using Ubuntu 23.10. In regards to the games I'm testing, a lot of them can really be divided into 4 categories. First we have FOSS games / native Linux ARM games, second we have emulators, third we have games that are native to Linux but not native to ARM, and finally we have Steam games / Windows games. So I started off with some basic 3D FOSS games. Extreme Tux Racer runs very well at 1080p with the maximum detail level. I can't verify the frame rate because the game doesn't have an FPS counter, but it does run very well, likely exceeding 60 FPS. Super Tux Kart also runs very well, still at 1080p albeit at low settings, and in this game we exceed over 90 FPS. Super Tux Kart is very lightweight for most modern x86 PCs, but having tested it on a netbook and on other ARM devices, it can certainly struggle, so it's nice to see a smooth experience here. Zero AD is quite varied. At 1080p low settings and with CPU throttling disabled, we average between the mid-20s and the low 40s, though at times I did go as high as 67 FPS. However, since it's not a fast-paced game, I'd say the experience is very playable. Though interestingly, some of the games I expected to run well actually ran pretty poorly. Open Arena and Quake 3 Arena are very sluggish, even if you drop the resolution right down. Meanwhile, Xonotic is completely unplayable, no matter how low you drop the settings. I don't really know why that's the case. Up next we have the Binding of Isaac demo, which is available as a native ARM app image. It runs pretty well as it's quite a simple 2D game, not much to really say here to be honest. Next we have Doom 3. Although the original game wasn't designed for Linux on ARM, it's possible to get it running thanks to a source port called DHEWM3. The performance is quite inconsistent, so it's difficult to give an exact frame rate, but we can comfortably reach 60 FPS at a low resolution, which honestly doesn't look too bad in my opinion. The only annoying thing is you have to restart the game every time you change a graphics setting. In the Box64 video I tested Minecraft Pi Edition, but that game is kinda boring. No offense. So what if you could play regular PC Minecraft? Well, you can. At least with the Java edition. I don't have the Bedrock edition, so unfortunately I can't test it. Although the official Minecraft launcher doesn't run natively, there is a third-party one called Prism Launcher, which is available as a flat pack on ARM. I wasn't able to get the latest version of Minecraft running, which is kinda sad, but I was able to get an older version, Minecraft 1.12.2 running. Not only does it work, it actually runs very well, at a resolution of 1152 by 864 on fast settings and 4 chunk render distance. We comfortably exceed 60 FPS and even go into the 70s on occasions. You can play the game at 1080p, but you won't be reaching 60 FPS. If you do decide to play at 1080p, I'd suggest turning VSync on. Although this makes the average frame rate lower, it makes the overall frame rate more consistent. But to be honest, I'm just impressed PC Minecraft even runs on a Raspberry Pi. Now we move on to emulation. Raspberry Pis are known for being good at emulation. In fact, retro game consoles are one of the most common projects Raspberry Pis are used for, and I even made one myself, so I didn't want to spend too much time on emulators. But I did want to test some newer consoles that my old Pi 2 can only dream of running. I started with Crazy Taxi on the Dreamcast using the Flycast emulator, where we get a solid 60 FPS using Vulkan and a resolution of 1280 by 960. And if you're wondering why I can't drive properly, it's because I couldn't find my Xbox 360 controller, so I'm actually playing the game with a flight stick. Plus, I'm also viewing my screen through my camera's viewfinder. I also tried running a Wii game with Dolphin emulator, but unfortunately I couldn't get any sort of controls working. For the next part of the video, we're going to be running PC games with Box86 and Box64, which I compiled myself. For those who aren't familiar, these are programs designed to emulate x86 and x86-64 Linux programs on ARM. Last time I had some trouble getting Box86 installed, which is needed for programs like Steam. However, I found a very helpful XDA developers article on how to install Box86, Box64, and also Steam on the Pi, which I'll have linked in the description. Let's start off with Helltaker. I'm actually using the itch.io version rather than the Steam version. For some reason it struggled quite a bit on the Quartz 64, but it runs beautifully on this Raspberry Pi, even at 1080p. This also means we know Box64 is working. By the way, you don't need Lutris to run these games. I just installed it so I don't have to keep opening up a terminal and digging through a bunch of folders to launch an executable. Next, I tried Ultrakill at 720p low. Again, no frame counter, so you're just going to have to take my word for it. It doesn't quite feel like it's at 60 FPS, maybe 45, but from my perspective it's still playable. Although I used to play TF2 and Skywars at 15 FPS, so maybe I'm just used to it. Another itch.io game, Supertux Advance, not to be confused with Supertux. I actually made a video about this game before, and I'd highly recommend checking it out. Much like Helltaker and Isaac, it runs just like it would on any x86 computer. And the final part of this video was getting some Steam games. Steam does in fact work when you get Box86 installed, but the Steam client is very slow. So once you install your game, I'd suggest you launch it through Lutris. I started with Papers, Please. Again, fairly simple game, runs just as well as it does on a regular PC. And finally, I wanted to try Half-Life. It is possible to run Half-Life without Steam by using X-3D, although I couldn't get it to work. Half-Life runs pretty well at 720p low, probably not as well as it could run, but it ain't too shabby. I did try some other Steam games, but unfortunately most of them either didn't work or were just completely unplayable. However, one of those games was Brawlhalla. I tested this game not because it's particularly demanding, but because it's not Linux native, and the fact the game launched is actually quite cool, because we basically have two sets of translation going on. We're using Box64 to run an x86 game on ARM, and on top of that, we're also using Proton to run a Windows game on Linux. So, I hope you all enjoyed. Like I said earlier, I have another video about the Pi coming up. This video is purely dedicated to gaming on the Pi, so if you're interested in how the Pi handles everyday computing or more sophisticated tasks, then keep an eye out. Until next time, cheerio.